Hey, living environment fans all across the globe. We're back on a Wednesday, which means, of course, it's book talk day today. Yeah, book talk. We've been reading The Hot Zone. We're wrapping that book up. I'm going to start a new book called Stiff, written by a woman named Mary Roach, who I think you'll really enjoy that as well. But we're on the 7th part of The Hot Zone, and we've been following the trail of the Ebola virus. And anyway, I'm looking forward to your take on The Hot Zone, Part 7. But let's do today's Bellringer, where we've been talking about the secret code of life, the secret code DNA, and how it's read.
All right.
Hey now.
Mr. Kovacs class. It's Mr. Kovacs class.
You might learn a ton.
It's Mr. Kovacs class.
It's interesting too.
It's Mr. Kovacs class.
And he's super cool.
It's Mr. Kovacs class.
All right, I introduced to you the code of life as a language. So it's like the language that ribosomes speak, right? They don't speak English, they don't speak French, they don't speak Spanish or Italian. They speak DNA. And DNA is a code written in 4 letters. It's a 4-letter alphabet to write all the plans you need to make all the proteins in the human body. And those 4 letters, as you remember, are A, T, C, and G. Right, 4 letters. T, G, C, and A. A, C, T, G. That's it. 4 letters in the alphabet. And then the rules of DNA is you put letters together in groups of 3, which are called codons in DNA, or we would call them, they'll be like words in English, right? Like DNA, CAT works as a codon. CAT works as a word. It's in English it works too, but it means something very different in DNA. GGC doesn't work in English, but it does work in DNA. Any combination of 3 letters works in DNA. CAG, that's a nonsense word in English, but in DNA it makes very much sense, right? And then you string words together, you get a long sentence of words, you get a long sentence of codons, you string codons together, you get what we call a gene. And 1 gene codes for 1 protein. This all starts in the nucleus with something called transcription, right? Transcription is when you want to make a copy of a gene. So the gene is here, right? This is what we want a copy of, this piece of DNA. Well, how do they make a copy of it? First you unzip it, and then you copy the other strand with what's called the anticodon, or the mRNA sequence, right? It's like an imprint of the DNA sequence you want. Then you send that out to a ribosome. And a ribosome, the ribosome, here we are. The ribosome can read that, right? It reads that mRNA. It reads it 3 letters at a time. Every time there's a group of 3 letters, it tells it which amino acid to put onto the chain, right? It's like a coded message. And it'll do that until it's told to stop. The amino acids are delivered by tRNA, transfer RNA, which deliver, right, they match up. If they have the right code, they match up. So, yeah, what gets confusing is that this mRNA code is not in DNA, it's in RNA, which is the anti-code of the DNA. It's like the opposite. So it has to be translated back into DNA at the ribosome. And we'll talk more about that as we go. The thing that's weird about RNA is that RNA has the same 4 letters. It says 4 letters too, right? A, C, and G. The only thing that RNA doesn't have is T. RNA has U's instead of T's. It's just a different chemical. Instead of thymine, they use uracil, and that's what RNAs use in replacement of a T. So when you're in DNA, you said A goes with T, C goes with G. In RNA, A goes with U, C goes with G. How's that for confusing? A guy named Marshall Nirenberg won a Nobel Prize for figuring out how RNA works with the different codons, right? But see, RNA has, so you're going to have to be able to read a chart like this as we work through the deciphering of the DNA code. But I think you can probably, right, read this chart. This is the first letter in the code, U, second letter in the code, C, third letter in the code, A. That gives you serine, an amino acid. So he figured out which code goes with which he basically Marshall Nurnberg cracked the language of DNA for us after what Watson Crick. This was about 6 years after Watson Crick got their Nobel Prize. And to be honest, it's only 1 year before Mr. Kobach was born. Right? So DNA and understanding this is not something we've known for a long time. We've only known it as long as about I've been alive, which to you may seem like a long time, but to me it doesn't seem that long. You know what I mean? We're going to keep talking about DNA and how to read the code and codons and anticodons and mRNA and tRNA and stuff that happens at ribosomes. It'll all come together. We just do it piece by piece. So right now, you know, DNA is a language. It's written in 4 letters. Letters are grouped into bundles of 3 to make sense. Each group of 3 codes for an amino acid at a ribosome. And you just string amino acids together at the ribosome to make a protein. As the protein is strung together, it bends and folds into the right shape. Right? So the shape is dependent on what amino acids are put into the right place. Right? It's all coming together, I think. Let's do this.